Okay, we are done what we call the energy, the electromagnetic energy formula. For this time, we'll try to solve a equation using this formula. So I haven't given you the what do you call this one? I did not give you the I haven't give you the I give you the formula, but I didn't give you the given or what we call this one, the specific name, right? So we have here the Planck's constant times with the frequency. Okay. Planck's constant. Right. Planck's Planck's constant. Sorry for my penmanship. I'm using computer. Okay, the Planck's constant and this on the F here is the frequency. So when we say Planck's constant, it is a constant energy or a constant time second, which is the movement of energy when it is at rest. So there is always a particular energy, even though you are just sitting down or the certain thing is not moving. So there's a certain energy. So that is called Planck's constant, which is definitely a constant one. So it's a 6.63 times 10 to the power of negative 34. And that is the Planck's constant with the unit of joule. Take note for this one, joule times the second. So, and about the frequency. Frequency is how often a certain wave moving, how often it moves. So it's gonna be using cycle per second. So it's using the unit of cycle per second, or we can call it hertz. So that is what we call the frequency. So let's erase this one first. Okay. So the next one also I also gave you the formula, which is I already gave you the formula, which is the velocity or the speed of propagation times with is equal to the wavelength times the frequency, right? Okay. So wavelength, this is the symbol for wavelength, and this is the frequency, and this is the velocity. So take note when you are going to finding out the frequency, this one will be derived, or and also the velocity we're going to use will be the speed of light in a vacuum, which is given. So okay, I already gave you the Planck's constant, and also the constant one for the speed of light is equals to 3 times 10 to the power of 8 meter per second. That is the speed of light. 3 times 10 to the power of 8 meter per second. So that is the speed of propagation when, take note, when you are going to find the frequency or the wavelength and without given any velocity. So you are going to use this, the speed of light. Okay, you're going to assume. Okay, let's erase this one. What if you are given a, what do you call this one? A equation, a problem solving like this. Are you able to solve this one? What is the energy? Take note, the first thing that you are going to do and answering a questions or a problem solving, you are going to look first. what is the given and what is the that you need to find. So here, what is the frequency and the energy of gamma rays with a wavelength of 9.8 times 10 to the power of negative 14 meter? So take note that this is a frequency and the energy. So this is the frequency and the energy that you need to find. So the first thing to do, we have here the formula, the energy, and we have here the frequency. So the first thing to do that you are going to find is the frequency, because we cannot get the energy without the frequency first. So we have given here wavelength. So we are going to derive the formula using this one. Okay, so since given the wavelength, and we can assume that there is the speed of light because there's no given velocity. So you are going to derive the formula, divide both sides all with the what? Wavelength. To cancel out the wavelength. Okay. So cancel out the wavelength till we canceled out. So we have now the frequency is equals to the velocity divided with the wavelength. Okay. So this is now the formula that you are going to use. Okay, I'm gonna erase this one. Okay. Okay. That's it. So we have here the frequency is equals to the velocity divided with a wavelength. Okay, that's it. And then since we have the given velocity, I mean, not given, it's a constant, 3, the speed of light, 3 times 10 power of 8 meter, meter per second. And then with a given wavelength of 9.8 times 10 the power of negative 14 meter. Okay. So the first thing to do here is you are going to cancel out the meter. So we'll be able to know that the frequency is also as a cycle per second, this one. This is the frequency, or it could be hertz. This also using this unit. So the same thing. So if you're going to I recommend if you're going to solve for the frequency, to get the frequency, you must always use the cycle per second so that you'll be able to know how to cancel out the unit. So we have here meter per second to cancel out this one. So we have now the second. So or it can be cycle second, assuming there's one there. So in when we are going to cancel out. So let's move. Zoom in this one. It's very zoom. Okay, anyway. So that's it one. So how are you going to get the frequency? To get the frequency here is you're going to divide. So 3 divide 9.8, it's 0.3. 0.3. So I'm gonna put it here na lang. 0.3 times 10 to the power of. So it's 8 and it's negative 14. Are we going to divide this one? No, no. We are going to subtract this one. Take note when you are going to, when there is a, what do you call this one? A division in every, this one, when there's a division of a certain numbers and it is an exponent. Take note when you are going to get the number of exponent, you need to subtract both sides. So 8, I mean, subtract the the 8 to the negative 14. So 8 minus negative 14. So we have the positive 22. So that our unit will be second. Cycle second. So that is how to get the frequency. Now we have the frequency. So we can also move this decimal point here to here. So this one will become 3 times 10 to the power of 21. That's it. Cycle second. Now we have this frequency. Now we can able to solve and to get the energy, right? So then, okay, I erase this one. So we have now the frequency. So our frequency is 3 times 10 to the power of 21 cycle second. And now we're going to get the energy, right? So since the energy is equals to um Planck's constant times the frequency. So we have the Planck's constant of 6 point. Okay, sorry. 6.63, right? Times 10 power of negative 34. Okay. Joule, take note the Planck's constant is Joule times second. Close and open parentheses since it's multiplication. And this one will be put it there, here. So, okay, I'll erase this one and put it there. Okay. So it's the answer is 3, the frequency is 3 times 10 to the power of 21, right? Meter per second. Close and open parentheses since it's multiplication. So we have here the energy. Okay. So take note, we need to cancel out the unit. Don't forget the unit. I know it's not meter per second, sorry, sorry. It's a cycle per second since it's frequency, sorry. This one is cycle per second. Okay. So the 6.63 here will be multiplied by the of 3 here. So when 6.63 times 3, it's a 19. Sorry, bad one. Okay. It's 19.9, right? 19.9 times 10. How about here? The negative 34. We can, what we're going to do when there is exponent on using multiplications, we are going to take note when this is exponent and it's a multiplication, you need to add the numbers, the exponent. Negative 34 plus 21, we have negative 13. So the exponent here will be negative 13. Cycle, not cycle, it's a cancel out the second, cancel out the seconds. Now we have the joule. So it's the energy. Take note, the energy has its unit of joule. So we have this one. This is the right answer. Okay, if you have questions, just comment down below. And if you have anything to ask, just message me. Goodbye and thank you, class. That will be all for today. Bye.